Hello, math fans. I have a student asking me a question about this problem in our homework that has to do with Matilda and her Wedge park. In talking about this, it gets me to explain what pi is. It's kind of an interesting question. And I thought, if Matilda's in there, I better mention this Matilda. So if you've never watched the movie or read the book by Roald Dahl about Matilda, it's quite lovely. Check it out. Pretty much all books by Roald Dahl are lovely. But so I threw in a few Matilda here as apologies to Roald Dahl. I didn't ask permission. But I don't know if this is who they had in mind, but that's who I think of. They say you have this park. The angle here is theta. Matilda definitely doesn't need our help because Matilda's really smart. If you've read that book. But they tell you this is R, this is R, and they tell you the perimeter. So the question basically says, I'm going to tell you the perimeter, and that's going to be different for everybody. I'm going to tell you the area, and I want you to find what R and theta are. And there's one other stipulation they give, which is that the angle needs to be an acute angle. Okay. And I can't remember. These are different. One of them's like 0.25 and one of them is something else, 3, 4, 5, 6. The real point of the question is, this is a great opportunity to use radians. Because the formula in radians for this length is way better. And the formula for area is way better. And that's because of what radians are. So if you use degrees, so that everything comes from the following place. This is the length all the way around a circle, and that's where pi actually comes from. Pi is what you get if you take the circumference and divide by the diameters. Long ago, someone realized that it's always about 3, but more precisely 3.1 and so on. So that's what we call the circumference all the way around. And this is what we call the area. If you want a proof of that, I have a nice visual of that as well. Check my posts. But what we try to do is get the fraction. So we take whatever we're calling the angle and we divide by what all the way around is. Now, if you use degrees, you divide by 360, which leads to kind of messy formulas. So instead, someone along the way said, well, why don't we just make that 2 pi? I said, well, that makes things kind of weird, but it makes the formulas nice. So this is the fraction of your circle. You multiply, you just get theta r, and that's what this is. This is the whole point of radians. If you go 1 radian, all 3 of those lengths are the same. A radian connects the angle to the length along the edge directly. And that's why it's so nice for certain things. So anyways, I'm going to leave this problem to my students. The perimeter would then be, I guess, 2r. But I'll finish with a little visual. And the area is 1/2 theta r squared. So this is one of these take it and shove it problems. They're going to give you a number here. They're going to give you a number here. And you're going to have to make a decision. Would you rather solve the first equation for r? Would you rather solve the first equation for theta? Whatever you do, shove it in the other one. It's like if you solve for theta here, take it, you shove it, and I do think you end up with a quadratic, and then you solve. Maybe you have to use a quadratic formula, in which case I think you get 2 answers. You have to remember that you want the answer less than 90 degrees. 90 degrees is the same as pi over 2, so you're probably going to want the smaller of the 2 answers. That's the game. But I thought I would finish with a little visual, because I always feel like for some students that little extra visual sometimes makes a big difference. So let me grab my visual here. Apologies, I just want to make sure I have it. Here we go. So here it is. So for those of you that love seeing a visual, let's do it. That maybe will make it more fun to solve, or maybe you've already fallen asleep. So here we go. I've made it so that I can move these things around in Desmos. And the perimeter, if you want a visual of it, is right here. That's all the way around. Again, I like making these visuals. And we're trying to make this for Matilda. So right now the perimeter is 5 miles as you see it. And the area is 1.05. Oh, did something weird happen at the end? I need to make that number a little bigger. There we go. Fun. Okay, so let's get rid of that. We know what the idea is now. I've made it so I can pull this out, which just makes the area and the perimeter bigger. I've made it so I can move this so that we can, let's go here. And so I made it experimental. Now I'm not going to share this graph with my students because then they could just cheat and try to find the answer. You're going to solve. So I think, again, it wants an area about this, but my perimeter's not right. So maybe I have to change it, but that changes the other one. It also wants the area to be a certain thing. So let's fill it in with grass. Let's put Matilda in there. She wants to be able to fit. Okay. So can you find that? That's the question that's being asked. Now you might say, what's the 90-degree thing? Well, if you go too far, you're going to run into this Matilda. We don't want that to happen. So there's probably two answers. One answer that's like short like this, that has a certain area. And one answer that's like this, that's a little further out. That's the one we want. So see if you can find it. All right, hope that makes that question more interesting.